Welcome to this webinar on the motions of Jupiter and Saturn and how they're connected to the 9-point circle. Jupiter and Saturn are the two giants of the solar system, the two biggest planets. Jupiter is bigger than Saturn, but not much, and Saturn has this magnificent ring system, which you may know. Jupiter also has a ring system, but it's quite faint and difficult to see. Jupiter is about 10 times the size of the Earth in diameter and about 1/10 the diameter of the Sun. So it falls in between as a geometric ratio 1 to 10 to 100. The 9-point circle is this device we use in Vedic mathematics. It's a circle divided into 9 equal parts like that, and it's numbered in this case anticlockwise. If you're familiar with the 9-point circle, you might be familiar with it going clockwise, but here it goes anticlockwise because the direction of the planets around the Sun are anticlockwise. So we make that slight change for consistency. The other thing to point out is because the circle is divided into 9 equal parts, each section is 40 degrees. So this angle here, for example, is 40 degrees, and so are all the others, and 9/40s of course make up your 360. So if I talk about the angle from here to here, that's going to be 80 degrees, 2/40s. Jupiter at the moment rises in the east about 11:30 p.m. most places on the Earth, and it's a prominent object of the night sky. If you get up in the early morning when it's dark and look to the southwest, you'll see Jupiter high up in the night sky. Brilliant. Saturn is 60 degrees to the left of Jupiter. So if you were to point at Jupiter and then turn your arm 60 degrees to the left and go down a bit, you'll be pointing at Saturn. At the moment the Moon is between Jupiter and Saturn, and they form more or less a straight line, so that would help to locate where Saturn is. Now this 60 degrees angle between Jupiter and Saturn is closing because Jupiter being closer to us than Saturn is, Jupiter moves faster against the stars than Saturn does. So Jupiter is catching up with Saturn. And eventually, of course, it will catch up with it, and there will be what's called a conjunction. And that happens in 2020. So, suppose we show on this diagram that Jupiter and Saturn have a conjunction here at some point, and that's actually going to happen on the 21st of December 2020. The period of Jupiter, that is the time it takes to go once round the Sun relative to the stars, is 12 years. And the period for Saturn is 30 years. It takes 30 years to go round. So Jupiter takes 12 years to go right round once, and Saturn 30 years. And if they're together here at some point, some time, then we might ask when we have another conjunction, when they are together at that point again. How long is it before that happens? When will the next conjunction be in the same place? Well, because it's a 30-year cycle for Saturn, it can't be less than 30 years. Saturn takes 30 years to go around here, and that's the first time it gets back here. Where is Jupiter after 30 years? Well, if we look at that 12 there, if you divide 30 by 12, you get 2.5. So Jupiter has done 2.5 revolutions in that 30-year period. So Jupiter will have gone round twice and a half and end up down here, and that's not a conjunction, that's called an opposition. But it does give us the answer to the question, because it means in another 30 years Jupiter will have gone round another 2.5 revolutions, and it will therefore have done 5 and will be back here. So the answer to the question is 60 years, two 30-year periods, and that means that Jupiter would make 5 orbits to Saturn's 2 orbits. And every 60 years this will repeat over and over in the same place. We'll get those conjunctions every 60 years, and so we could say that in 2080 there will be another conjunction of Jupiter and Saturn in the same place. And it's worth noting that the lowest common multiple of 12 and 30 is 60. Now suppose we don't have this restriction that the conjunctions have to be in the same place, because in fact Jupiter will overtake Saturn before that 60 years is up. So we're going to ask now, when will the first conjunction be? And we'll note that for Jupiter it covers 30 degrees a year. Because it's got a 12-year period, it covers 360 degrees in 12 years. So if we divide 360 by 12, we get 30 degrees per year. And similarly for Saturn, if you divide 360 by 30, you get 12, so it's going at 12 degrees a year. So that means that after a year, Jupiter will have gone 30 degrees, say to here, and Saturn will have gone 12 degrees. And the difference between them is 18 degrees. 30 minus 12 is 18. So every year Jupiter will be further away from Saturn by 18 degrees, or if you like, it's catching up with Saturn at 18 degrees per year. Jupiter is approaching Saturn at 18 degrees per year. If you imagine two runners going round in a track, one going faster than the other, like Jupiter is here, then Jupiter is going to catch up with Saturn eventually. Well, we could say that Jupiter is 360 degrees away from Saturn, and it's gradually reducing that distance, that 360 degrees, at a rate of 18 degrees per year. So how long will it take to cover that 360 degrees at 18 degrees per year? Well, the answer will be 360 divided by 18, which is 20 years. So in 20 years the next conjunction will occur. And we might ask now, where will that conjunction happen? And we can find that out by thinking where Saturn and Jupiter are at 20 years. If Saturn covers 12 degrees per year, then in 20 years it'll be 12 times 20 degrees, or 240 degrees. So it's gone all the way around from here to here. What about Jupiter? Well, Jupiter goes at 30 degrees a year, so in 20 years it's done 30 times 20 degrees, 600 degrees. That's 360 plus 240. It's a full revolution and another 2/3 of a revolution. So it's gone round once and then another 2/3. It ends up here, and that confirms that we do actually have a conjunction there, J2S2. And we can use this result to get the next conjunction, because if Saturn goes 240 degrees from one conjunction to the next, it'll go another 240 degrees for the next conjunction. It'll be here. And Jupiter will also be there. It'll do, from here, it will do 1 2/3 revolutions and end up here as well. So we get this cycle going from here to here to here, repeating over and over. And it's a 20-year cycle. Now we're going to look not at conjunctions but at trines, and a trine is when you've got an angle of 120 degrees between two planets. So one is in one direction and the other one is 120 degrees in a different direction. That's a trine, and we need to show these, well, we don't have to show these but we're on separate diagrams, but we will. We're going to show Jupiter on the left and Saturn on the right, and the positions of the two planets when they're in trine, when they're 120 degrees apart. So it's color-coded. Jupiter's in red, Saturn's in blue on the right. So we use the fact that Jupiter is approaching Saturn at 18 degrees per year, and we ask, when will the first trine be? Okay, they're together here, and then Jupiter moves away from Saturn. Saturn's also moving this way. After a while they've got an angle of 120 degrees between them. So when will the first trine be? It'll be when there's an angle of 120 degrees, and that angle is being created at 18 degrees per year. So we need to divide 120 by 18, and we get 6 2/3 years. So after that period of time there will be an angle of 120 degrees between the two planets. And where does that occur? Well, as before, we can work it out. We can work out where Jupiter and Saturn are after this period of time. So for Saturn, it does 12 degrees per year. So in 6 2/3 years, we need to multiply 12 by 6 2/3 and we get 80 degrees. And for Jupiter, at 30 degrees per year, after 6 2/3 years, it's done 30 times 6 2/3, which is 200 degrees. And if you look at those numbers, 200 degrees, 80 degrees, you'll see that there's a difference of 120 degrees between them, which is what we want. That's a trine. So Saturn starts here, and then there's a trine at 80 degrees, so I can draw a line across like that. That's the conjunction, that's the first trine. And that will repeat every 6 2/3 years. Saturn will advance by 80 degrees, and so this is repeated like this. And we get this pattern which repeats over and over. For Jupiter, we can do a similar thing. We've got our first line will go from the conjunction here to 200 degrees. It goes around 200 degrees. We've just worked that out. So that's that line. And then another 200 degrees from there will take us around here somewhere, like that. And then that will repeat every 200 degrees, and we get this pattern. And what we find is that we get these two diagrams, which, if you're familiar with the multiplication tables on the 9-point circle, may surprise you that we've got the same diagrams here. This is the multiplication table pattern for 5 and 4. I'll explain this more in a minute. And this is the pattern for the multiplication tables 2 and 7. Here in green you can see the actual first trine drawn out. We said that after 6 2/3 years, Saturn is at 80 degrees, which is there, and Jupiter is at 200 degrees, which is there. And you can see that's 340 is 120 degrees. And that's the second trine in orange. So what this diagram on the right here shows is successive positions of Saturn for which it's 120 degrees from Jupiter, or some multiple of 120 degrees. Now let's go back to those multiplication tables. This is the table for the 2 times table. Okay, familiar with this? Multiplying all these numbers by 2, and these are the results. And what we do is, if we get a 2-figure number, we add the digits up. So 1 and 0 becomes 1, 1 and 2 becomes 3, 1 and 4 becomes 5, and so on. And we get this sequence. And if we plot those on the 9-point circle, we get the same diagram as on the previous slide. 0, 2, 4, 6, 8, 1, 3, and so on. So it's quite a remarkable thing that we do get these multiplication table patterns out of the configurations of Jupiter and Saturn. And the 5 times table 2 is here, and we make the answers into single digits by adding them up if we get a 2-figure number. So 1 and 0 is 1, 1 and 5 is 6, and so on. We get this sequence which generates that pattern. So this is quite nice. It means that we can actually make predictions about future configurations of these planets. So for example, if you're interested in the second trine, we go to the 2 here and we multiply 6 by 6 2/3 years it takes between these events. So we get 13 1/3 years. After 13 1/3 years there will be a trine at 1, which is here, which is 40 degrees to the left of the first 0 point, the first conjunction. So it's all contained in the multiplication table and the 9-point circle. Also, if you look at those periods again, for Jupiter it's a 12-year period and for Saturn it's 30 years. And if you divide out the common factor of 6 here, you get 2 and 5, which are the multiplication tables we've got here. Looking back at the 20-year conjunctions, we had this pattern. When you remember from here to here to here, every 20 years we get these conjunctions, and this is like the multiplication tables for 3 and 6. It's most like the 6 times table that goes 0639 repeated, so 0639 goes round like that, and this is similar, it just goes the other way round. And the 60-year conjunctions, you'll remember they always occurred at the same place, and that's like the 9 times table, because if we add up the digits in the 9 times table we get a series of 9s. So putting all those together, we've seen that the 4 and 5 times table come out of Jupiter trines, the 2 and 7 times table, the Saturn trines, the 3 and 6 times table are the 20-year conjunctions, and the 9 times table is the 60-year conjunctions. Well, you may notice that there is a couple of tables missing, the 1 and the 8 times tables, which look like this. This is the 1 times table going this way. We have 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and the 8 times table goes the other way round. So the question is, what configuration of planets, what configuration of Jupiter and Saturn would give us, could give us, this particular pattern? Can we work backwards and find out what the relationship between Jupiter and Saturn might be that leads to this pattern? Well, let's see. Supposing we think about Saturn going from here to here. That's 40 degrees. And if it keeps on doing that, then we will generate that pattern that we're after. So how long does it take Saturn to cover that 40 degrees? Well, it's going at 12 degrees per year, so it will cover 40 degrees in 40 divided by 12, which is 3 1/3 years. In 3 1/3 years it goes from here to here, and in another 3 1/3 it goes to there, and so on. So that generates the pattern. Now let's see what happens to Jupiter in 3 1/3 years. Well, Jupiter covers 30 degrees for a year, so after 3 1/3 years it will have done 30 times 3 1/3, which is 100 degrees. So Jupiter is going to be that 40, 80, 100 down here. And so we can show Saturn being here and Jupiter being here. That is 40 degrees round and that is 100 degrees round. So if you put in a vertical, that's 40 degrees there, and that's 100 degrees all the way. The difference is 60 degrees, and so that is 60 degrees, and that's called a sextile. When there's an angle of 60 degrees between two planets, it's called a sextile. So when there's an angle of 60 degrees between Jupiter and Saturn, or a multiple of 60, we will get these positions for Saturn, and we might ask what are the corresponding positions for Jupiter. Well, we know that Jupiter starts off at 100 degrees, so starting here, 100 degrees is here, and then after another 3 1/3 years it will go another 100 round, which takes it to here, and we can continue that sequence until we complete the pattern and it starts to repeat. And we get this, which is really on an 18-point circle. So we can now conclude and say that our pattern for the 1 and 8 times table is represented by the Saturn sextiles. Now let's look again at those trines. What we're saying here is that this diagram on the left shows the positions of Jupiter, successive positions of Jupiter, when it's in trine with Saturn, when the angle between Jupiter and Saturn is 120 degrees or some multiple of 120. But in fact not all of these are proper trines, because some of them are conjunctions. 360 degrees, for example, is a multiple of 120, but it's not really a trine because the planets are together rather than at 120 degrees. And that means that every third position should be discounted. Or if you look at the multiplication tables, it means that every third row should be crossed out, every multiple of 3. We're going to do Saturn first. If we want to draw out the trines for Saturn, excluding the ones which are conjunctions, then we get a slightly different pattern. So we won't start here because that's not really a trine, that's where they're together. We start here, and that's the first trine and that's the second trine. So we get that line there. And then, instead of going to here and then here, we go directly to here because this is actually a conjunction, like that. And if we complete the pattern, we get this. Now, I don't know if you saw the last webinar about the yantras, which Vinay Nair did, or maybe Vinay's here. Maybe you recognize something about this shape. It's actually very similar to the Durga yantra that he introduced us to. In fact, if you add that equilateral triangle for the conjunctions that we had earlier, you'll see it's even more similar to that. So I just thought I'd mention that. Now let's look at Jupiter and see how we can translate its trines, leaving some of them out. So we don't start here for Jupiter, we start here. And the first two trines are this and this, so that gives us this line. Then we don't go to here and then here, we go directly to there because this is not a trine. So it's like that. And then we complete the diagram for that. In fact, you see how this central triangle appears over here, and these three triangles fit in these three spaces, like this. Also, it's worth noting that the central part of this diagram is this diagram over here. Well, there's a lot of material here which could be used in schools, even for quite young children. So that really completes my presentation, and I hope you see that there's a lot of scope for further work here. And some ideas for that are, first of all, we can use more accurate values for the periods of Jupiter and Saturn and get more accurate conjunction patterns. The actual period of Saturn is more like 11.86 years than 12. And for Saturn it's not really 30, it's a bit less, 29.46, but you'll see they're very close to 12 and 30. So we get this pattern if we use 12 and 30, we get this pattern. What happens if we use the more accurate values? What happens is that the first line falls short by about 2.5 degrees in fact, and that 2.5 degrees sort of builds up, and you get a diagram like this. So what's happening is we still get this equilateral triangle, but it's actually rotating. It takes about 3,000 years to go around once completely. And so we can build that into our calculations, and we can take allowance of it, the fact that it's rotating at a known rate, and get more accurate values for the conjunctions. And the same for the other diagrams too. The 9-point star is rotating in the same way. Another thing we may consider is that in our calculations we've had the Sun at the center. We've had a heliocentric system. And what happens if we translate to an Earth-centered system? We get a slightly different pattern for the positions of the trines or conjunctions or whatever. Here I'm showing the trines, and in fact it turns out to look like this, where the whole diagram is skewed towards the initial conjunction. Another idea for research is recurring decimals, because for example if you take the fraction 1/7 and convert it to a decimal, you divide 7 into 1 and you get these numbers 0.142857 repeating over and over, and those can be plotted on the 9-point circle 1, 4, 2, 8, 5, 7 and then back to the beginning 1 again, and that repeats over and over. So we might ask, can we reverse what we've been doing here and find out some motions of planets which gives rise to this pattern on the 9-point circle? So to summarize, we've seen that there's a correspondence between the configurations of Jupiter and Saturn and the multiplication tables. They're all connected together, and we can make predictions from the multiplication tables alone or from the 9-point circle. And there's scope for a lot of further investigation. We can also look at oppositions. We've only looked at conjunctions and trines and sextiles here, but we haven't looked at oppositions when the planets are on opposite sides of the Sun, quadratures where there's 90 degrees between them, quintiles where they're separated by a fifth of a circle, and so on. And we can look at other pairs of planets or groups of planets, like Venus and Mercury, for example, which has a similar ratio to Jupiter and Saturn. You can take any pair or group and study the configurations between them and show them on diagrams. So thank you very much.